Boil-off gas management at sea depends largely on the type of propulsion system in use on the LNG carrier, and market forces. When LNG prices are high, the ship is under pressure to discharge as much cargo as possible to maximize income. The ship also needs to retain cargo on board to keep the cargo tanks cool and for propulsion fuel. During a normal discharge, the main cargo pumps will be used, and a quantity of cargo will be retained on board for keeping the cargo tanks cold on the ballast passage. The quantity to be retained on board depends on the duration of the ballast passage. During discharge, LNG vapor is supplied from shore to maintain pressure in the cargo tanks. The main cargo pumps discharge LNG to the main liquid header and then to shore via the midship liquid crossover manifold connection. Each tank is discharged down to about 0.2 meters level, and the heel tank will be at a level depending on the duration of the ballast passage, expected elapsed time before loading, and the volume of boil-off gas estimated to be required by the ship's boilers. During longer ballast voyages, the lighter parts of the liquid in the tanks will evaporate, practically leaving LPG warmer than -100 C in the bottom of the tank, and a great likelihood of positive temperatures at the top. In this event, the tanks will have to be cooled before loading can occur. Cool down is achieved by introducing LNG to the tanks via the 2 spray rails/rings in each cargo tank. The method used for cooling the cargo tanks depends on the operating condition of the ship. Tanks can be cooled just before arrival at the loading terminal. A quantity of LNG heel not exceeding 10% of tank length is retained in one cargo tank on completion of discharge. The cargo tanks are kept cold by periodically spraying the tanks with LNG to maintain -120 C to -130 C inside the tanks. Expected boil-off rates for heel quantities are 50%. We can also cool down the cargo tanks with LNG supplied from ashore.